Hello friends, welcome to CEC Live Lectures. Dear friends, with our ongoing series on cloud computing, today we are going to talk on scheduling of cloud computing. And for the discussion on the topic, we have with us in our studios Dr. Kashish Ara Shakil. Dr. Kashish Ara Shakil is Assistant Professor in Department of Computer Science and Engineering, Jamia Hamdard. Dear friends, Dr. Kashish Ara Shakil is a prolific professor, and through her we always get in-depth knowledge on various topics and issues related to computer sciences. Friends, if you wish to ask questions on today's topic from Dr. Kashish Ara Shakil, then do call us to our toll-free number. Our number is 1800-110-430. I repeat, our number is 1800-110-430. All dear friends are requested to call in the last 10 minutes of the lecture only, as well as you are requested to ask questions relevant to the topic only. Now, I would like to welcome our guest, Dr. Kashish Ara Shakil, once again. Hello, ma'am. Welcome to the lecture.
Hello, everyone. In this series on cloud computing, till now we have discussed about what cloud computing is all about. Then we had discussed the different benefits of cloud computing, then the different issues which arise from cloud computing. Then we moved further towards more advanced topics like load balancing. So continuing with the advanced version of cloud computing, today we will be discussing about scheduling in cloud computing. This topic is particularly of interest to the people who are doing research in cloud computing. So we'll be taking up on the different cloud computing scheduling models which are being used, the different algorithms which are being used for scheduling of resources in cloud computing. So what cloud scheduling is? Cloud computing, as we all know, is a very emerging technology, and it allows processing of huge amount of data. But if we have to process huge amount of data, then what is the background, what is the infrastructure which is required for processing this huge amount of data? Because for us as a users, we are just sending our demands to the service provider. But what actually takes place at the cloud service provider's end? Because cloud service providers, they provide you with an illusion of infinite amount of resources, but in the real life there's nothing called as an infinite. It is just an illusion which is provided by the service providers to its users. So how this illusion is created at the service provider's end, this all is done through scheduling and through scheduling algorithms which are exploited at the infrastructure, at the service provider's end. So scheduling, I said we are going to do scheduling, but what scheduling of what? So basically in cloud computing, what we are doing is we are going to schedule how the resources are being provided to the clients. So what are the resources in cloud computing scenario? Here the resources, as we have already discussed, these resources are the resources which a user demands. So these resources can be CPU, they can be RAM, they can be network, they can be bandwidth, etc. So how the service providers work towards providing these resources in an infinite manner to the clients. This all is handled by the scheduling algorithms. So basically, why do we go for scheduling? Why just not provide the resources as and when a demand is comes up? So if we do not provide the if we do not have any scheduling algorithms at the service provider's end, what we are going to end up with is we are going to end up with a deadlock, because it might happen that some of the users, they might have purchased the cloud services in terms of high priority. So in such a case, it might happen that at the service provider level, all the services, all the resources which are being provided to the users are engaged with one user, and the other user has to wait. But this kind of scenario is not possible in cloud computing, because cloud computing, the services which are being provided, they are nothing but they are a kind of business. So if the demand is not catered to by the service provider, then what is the use of any client coming to the service provider end? So in such a case, cloud scheduling plays a very important role. So what basically scheduling does is it helps in increasing the performance and better utilization of resources. So if we have developed such algorithms which are able to utilize the resources which are being provided to the service provider in a better manner, in an optimal manner, it would eventually end up providing better performance of the service providers. So scheduling, it basically plays a very important role in cloud computing for mainly for better management of resources and for improving the performance of the kind of services which are being provided by the service providers as well. So scheduling is a kind of heart of cloud computing, because if you are not being provided the resources which you are asking for as a client, then why do I go for cloud computing? Why not I just have a setup of my own and then I start off with my own resources? I do not, as a client, want to wait for the service provider to just help me and give me my services. So it is basically a kind of heart of cloud computing, because if your scheduling it fails, then the entire cloud computing it will fail eventually. So then there are things called as workflow or job scheduling under the platform as a service. So basically in cloud computing there are different levels in which scheduling can take place. One is at the job level, or we can say the workflow level, and another level is the virtual machine scheduling. So at the job level, it is a kind of platform as a service, because you are going to provide computing platform to the jobs which are making a demand for the resources. So for a service provider, every task which a client hits, every task which a client submits to the cloud service provider, these tasks are considered as a job. So whenever I am servicing if I am a client and I am sending request for any particular resources, my request will be treated as a job. It will be treated as a task by the service provider, and they will be taking care of the kind of task which is being submitted, and they will be scheduling these jobs which I am submitting. And at their own level, at the service provider level, what they are going to do is all these services which are being provided to the clients at the service provider level, like we have already discussed in the previous lectures, virtual machine technology plays a very important role, because all these services, all the infrastructure which is being provided by the service providers to its client is provided in form of virtual machines. So these scheduling of these virtual machines is also important, because if the term is virtual, it does not mean that at my service provider level I will have an infinite amount of virtual machines. That is also a finite entity. One point I want to make clear here is ever since we started talking about cloud computing, we were talking about cloud computing providing us infinite amount of resources. So why I'm saying that here at this point that the resources are finite? Actually, the thing is, there are two perspectives. One is the client perspective and another is the service provider perspective. So from the client perspective, if I am a client, for me, what a service provider does is it will provide me with an illusion that the resources are infinite. I can just hit a request for any amount of resources at any point of time from any geographical location. That is high availability. But for me as a service provider, how I'm going to provide this illusion, because for me as a service provider, my resources are fixed, but I am going to create an illusion. I am the illusion creator that the client will see that the resources are infinite, but I know what the reality is. In reality, for me as a service provider, the resources are fixed, and for the client, these resources are infinite. So virtual machines also are finite, because in today's lecture we'll be talking from the service provider's perspective. So the virtual machines which are available are also fixed, because these virtual machines are eventually created out of my physical hardware. So these virtual machines, the number of virtual machines are also fixed. So I need to schedule these virtual machines also in a manner that the resources are provided, these virtual machines, these infrastructure are provided in an optimal manner. So what scheduling does at this point of time is it has to take care of that which job and which machine should be scheduled. Like we have a pool of jobs, then we have a pool of virtual machines. So which job will go to which virtual machine, this is decided by the scheduler. So this is what scheduling is all about. A client will submit requests. These requests will be treated by the service provider as a job or a task, or maybe say a workflow, and the service provider has a set of virtual machines at its end. So how these tasks will be mapped to these virtual machines is decided by the scheduler. And how the scheduler decides it? By its underlying algorithms. What are these algorithms? We'll discuss in the upcoming slides. So cloud scheduling, apart from providing optimum utilization of resources, what else it does is it reduces the operational cost. It reduces the waiting time for clients, because waiting time is also very crucial. If I have to wait like for 24 hours for just accessing a particular configuration machine, then what is the point I'm going for cloud computing? So for better performance, cloud scheduling should help in reducing the operational cost. It should reduce the waiting time, and it should increase the utilization of resources, so that the entire cloud infrastructure, the entire cloud ecosystem could work in harmony with one another. So let's look at what job scheduling is. So as we already discussed, when we are dealing with job scheduling, or when we are talking about job scheduling or workflow scheduling, we are talking of platform as a service. So workflow scheduling, it plays a very important role in management of workflows. So what a workflow is, because I don't think we have talked about workflows in our previous lectures. A workflow is basically nothing but it's a set of tasks which can be submitted by the users. So how these tasks are scheduled, that is workflow scheduling. So workflow scheduling, it plays a very important role in management of workflows or the tasks which are present in the workflow. A common model is constituted by workflows to describe a scientific application wide range in a distributed system. A cloud workflow system, it comes under a specific service provider and under its cloud resource managers management. So basically, as we have already talked, that workflow scheduling, it comprises of a set of tasks. So basically there are different kinds of workflow. They can be scientific workflows. For example, there is a very famous workflow called as CyberShake. And so apart from that, there are many other workflows. Scientific workflows are something which are built for a particular scientific application. We have CyberShake, and apart from that, other workflows. So so these workflows, they have a set of tasks. So how these tasks will be managed, how these resources will be provided to to cater to the tasks which are submitted, that comes under workflow scheduling and is taken care of by the cloud resource manager. Then apart from that, we have also talked about virtual machines. That virtual machine is basically part of the infrastructure as a service, and there can be multiple virtual machines. So how these virtual machines are provided to the jobs, that is taken care of by the virtual machine scheduling in cloud computing. But why is scheduling actually required in cloud computing? Why not just go ahead and just provide resources? Why is it actually required? We already talked about it is one of the cases is better utilization of resources, then increase in cloud computing performance, and the next point, which we have not discussed till now, is it reduces the amount of energy which is being consumed. How the energy consumption is reduced? Because in cloud computing, what happens is cloud at the service provider level, what is there are loads of infrastructures, and these infrastructure, they will be using up a lot of energy in terms of electricity, and they will also be dissipating a lot of energy in terms of heat, noise, etc. So if you're using the resources in an optimal manner, naturally you will be utilizing less amount of resources, and there will be less carbon footprints which are generated. So overall, in Symphony, what is happening is you are going to reduce the amount of energy which is being consumed, and naturally if the resources are less, the cost of using these resources would also be less. So how should our cloud scheduling algorithms be designed? What should be the objective of these scheduling algorithms? Because at the core we have infrastructure as a service, and we have all these services are provided by the service providers. So at the background, at the back end, how these service providers are providing these resources through their scheduling algorithms. So what should be the objectives of these algorithms which are developed for scheduling? First is there should be fair resource allocation. It should not be that all the resources are being allocated to one user only, and the other user who is of equal priority is left starving. This should not be there. These resources should be allocated in a fair manner. Then quality of service should also be taken care of. It should not be like, okay, I'm able to cater to thousands of clients with the given infrastructure, and but the thing is, these clients, they are suffering. I'm offering very poor quality of service. I will naturally end up losing my business because my clients are not going to stay if I'm going to provide them with poor quality of services. So maintaining the quality of service is also very important when designing cloud scheduling algorithms. Then another very important aspect which needs to be taken care of, that we should maximize the resource allocation, utilization. So because if the resource utilization is not optimal, because actually the thing is, resource utilization itself as an entity is linked to many other aspects, like it is linked to energy consumptions, it is linked to cost, and of course it is linked to the performance also. So if your resources are utilized in an optimal manner, in a fair manner, what happens is naturally the cost of your resources will go down, and the performance will increase. Throughput of the services which are being provided would also increase. So it will one of the objectives, very important objectives when designing a scheduling algorithm for cloud computing, is the resource utilization should be maximized. And another very important thing which needs to be taken care of is energy consumption should be reduced. Actually, in the earlier times, initially when cloud computing was designed, people were not very much bothered about the energy consumption aspect, but this energy consumption is in itself developing as has emerged as a discipline in itself in cloud computing. So energy consumption is something which everyone is moving towards when it comes to cloud computing. So they are so it is a very important objective which should also be taken care of when we are designing our cloud scheduling algorithms. There have been many cloud computing scheduling algorithms which have been proposed by different researchers. So just like in say how you can identify with these is like in case of operating system, I'm sure all the students of cloud computer science, they might have studied operating systems till now, or they might be having a fair idea of what operating system is. So in any case operating system, basically what the main resource is your CPU and RAM. How these resources are provided to a task, that is done through different algorithms, like there are different algorithms like round robin, first come first serve, shortest job first, then priority scheduling algorithms. These are all the traditional algorithms which I'm sure any student who has studied or taken up a course on operating system must have studied these algorithms. So in a very similar manner, cloud computing scheduling is also developed, and it also revolves around certain algorithms which are very similar to the ones which we had already studied in traditional operating systems. The different algorithms are like FCFS, then we have round robin, min-min scheduling algorithm, max-min scheduling algorithm. Then we have other algorithms like meta-heuristic scheduling algorithm. Then there are certain static scheduling algorithms. Apart from that, there are many dynamic scheduling algorithms as well. So now let's have a detailed understanding of what these algorithms are. First one is first come first serve. So like in traditional operating system, what happened was whenever a task was being submitted, it was being assigned resources as soon as it comes. So if there are say 5 tasks and there are 5 resources, so when a task comes and it makes a prompt to the operating system that I want such and such resource, then these tasks are provided the resources on the manner in which they arrive. In a similar manner, in cloud scheduling also, we have an algorithm called as first come first serve algorithm. What it does is, this type of scheduling algorithm is basically based on first job which comes and how it is served. So whichever job comes first, we are going to serve it first. So so the basic technique which is used is FCFS, or first come first serve. So here, as we are talking in about these client request in terms of jobs, so whenever a job comes, it is being assigned resources. So how the cloud computing it is using these FCFS algorithms are, it uses FCFS to send data in terms of packets form as it is received by the router at the sender end, and as well as the router on the receiver end. So basically, as and when a service request is being made, these services are provided to the client or the job. So whenever a job is submitted, it is being provided resource. This is very simple and very similar to the operating system level scheduling. So just assign the task coming first with the resource which is available. So the next one is round robin scheduling algorithm. So round robin scheduling algorithm is also very similar to the one which we have been used which we have been using in traditional operating system algorithms, that the entire tasks are being assigned some time quantum which is being distributed to the different tasks which are coming up. So we will be discussing more on the round robin algorithms, and apart from that we will be discussing about more other algorithms based on scheduling in cloud computing in the second half of the lecture. So we will just stop here for a short break.
With this note, thank you, ma'am. Thank you so very much for giving us this session on scheduling of cloud computing. Dear friends, you are requested to be with us as we are back after a short break, and we are going to give you more knowledge. Thank you for watching us. Hello friends, welcome back to this session. Friends, as you know that today we are talking on scheduling of cloud computing, and for the discussion on the topic we have with us in our studios Dr. Kashish Ara Shakil. Dr. Kashish Ara Shakil is Assistant Professor in Department of Computer Science and Engineering, and it is one of the important departments of Jamia Hamdard. Friends, we know that you might have lots and lots of questions regarding today's session. So if you wish to call us, you can talk to us through our toll-free number. Our number is 1-800-110-430. I repeat, our number is 1-800-110-430. Now I would like to welcome our guest, Dr. Kashish Ara Shakil, once again. Hello ma'am, welcome to the lecture.
Hi. So before the break, what we had been discussing about was the different scheduling algorithms. We have discussed FCFS, and we were talking about round robin algorithm, and we had discussed about round robin algorithm in a traditional operating system. So how this algorithm works in cloud computing, let's see. So round robin scheduling algorithm was designed based on CPU time distribution among the tasks of the schedule, just like a very normal operating system round robin algorithm. Here the CPU time is distributed among the different tasks in a schedule. And what happens is all the tasks, they are present in a queue list, and each task will be getting a small unit of CPU time. So what this CPU time is known as, it is known as quantum, very similar to the one in operating system. So what we have is, we have a set of tasks which are present in the queue list, and each of these tasks will be getting CPU time for a small time quantum. So it is very similar to the traditional operating system algorithm. But the thing to be noted here is that the time quantum here in case of cloud computing can be in a range of around 10 to 100 milliseconds. So if we have, say, like 4 tasks, task T1, or we can say jobs, as we have been talking since we started off with this today's lecture, we have tasks or jobs. So if you have like 4 tasks, they will be assigned different quantums of CPU. So for example, if we have 4 tasks, then the CPU time quantum will be divided, and it might be like task 1 would be assigned quantum 0, and task 2 will be assigned the second time quantum, third time quantum, and so on. So in this way, the different tasks will be assigned different time quantums of the CPU. Next algorithm is min-min scheduling algorithm. So these are all the algorithms which we are talking about now are the ones which have been proposed in different research papers. So another algorithm is min-min scheduling algorithm. So basically what min-min scheduling algorithm does is, it basically works on the mechanism of determining the minimum completion time for each job which is submitted for execution. So what is the minimum time which is required for completion of this particular job? So every job or every task which is submitted by a user, it has to undergo 2 steps in case of min-min scheduling algorithm. In the first step, what the algorithm does is, it basically sees the job and sees, as we say that if in case multiple jobs are available. So what this algorithm does is, firstly it picks up the job with the minimum completion time or the minimum execution time from the pool of jobs which are available, and from this set of jobs it allocates the resources to the job. So the job having minimum execution time is basically provided the resource first in case of min-min scheduling algorithm. So it's a very simple algorithm, just based on the minimum execution time. So but I think it will have certain constraints, like you need to know the execution time beforehand. So this is, I think, one of the drawbacks of this algorithm. We'll be discussing on the drawbacks and different comparisons of the algorithm towards the end of the lecture. Next algorithm is max-min scheduling algorithm. So what max-min scheduling algorithm is, it is basically a selective algorithm based on max-min scheduling. So it functions exactly like the min-min scheduling algorithm, but the only difference is, it basically, instead of selecting the job with the minimum execution time, now what it is going to do is, this algorithm will select the job with the maximum execution time, and then it will assign the resources. So it is just a kind of opposite, and works similar to the min-min scheduling algorithm. So in min-min scheduling algorithm also, what the drawback was that you need to know the execution time of the algorithm beforehand. Here also you need to know the execution time beforehand. The only difference here is, in min-min scheduling algorithm it was selecting the job with the minimum execution time, and in max-min algorithm what it is doing is, it will be selecting the job with the maximum execution time, and then it will continue to work on the jobs in a descending order. Another scheduling algorithm is meta-heuristic scheduling algorithm. So what a meta-heuristic algorithm is, let's see. According to researchers Osman and Laporte in 1996, they had proposed in their paper that a meta-heuristic scheduling is basically an iterative generation process which guides a subordinate heuristic by combining intelligently different concepts for exploring and exploiting the search space, the learning strategies that are used to structure information in order to efficiently find a near optimal solution. So what it is going to do is, it is going to combine different concepts of exploring and exploiting the search space, and then coming up with a combined intelligent solution which is optimal also and works in an efficient manner, and provide meta-heuristic scheduling. Then another algorithm is static scheduling. I think even min-max, they will also come under static scheduling. So basically what static scheduling algorithms they work on is, they will work on pre-information. So whatever information you need for your creating a schedule, you need to know it beforehand. So what kind of informations that might be? It might be the amount of resources that you need, it might be the amount of time you require to complete a particular job, or if there is any chance of any kind of error, what is the behavior of the jobs, etc. So everything you need to know beforehand, which is not always possible on the real world. So people generally, they move towards more dynamic algorithms, but from the experience and from the experiments of different researchers, even static scheduling algorithms, they help in providing scheduling in an optimal manner. So there's always a discrepancy, but whether static scheduling should be adopted or dynamic scheduling should be adopted. So but the results, they have their own pros and cons, and for a service provider, before adopting any kind of scheduling technique, whether he's going for a static scheduling technique or they're going for a dynamic scheduling technique, they should take care of all these pros and cons and then decide upon which scheduling algorithm they should go for, whether they should go for static one or they should go for a dynamic one. So static scheduling is basically based on pre-information. The resources are scheduled before the actual start of execution. One very important point to note here is that the resources are scheduled, they are not actually allocated at this point of time, but a general kind of schedule is generated beforehand that these resources will be assigned to such and such tasks, and so you have a general schedule beforehand, and then when you are actually running the algorithm, what you are going to do is you are going to follow that schedule, that this task will be assigned to this resource and this resource will be assigned to this task. So this schedule should be generated beforehand. So even for generation of these schedules, these static schedules, there are many meta-heuristic algorithms which are being adopted, like ant colony is widely used, then we have particle swarm optimization which is used, and in fact there are many scheduling algorithms for cloud computing, particularly for scientific workflows, which have been developed based on particle swarm optimization, then ant colony optimization, and they're published in very good journals. So so it means that static scheduling is also very important. And so what these algorithms do is they create a general schedule beforehand, and then when the actual execution takes place, then the actual resources are assigned. Then once the execution is started, it is not allowed to change, of course, because it is static. So if something is static, it means it will not change. So to sum up about static scheduling is basically, in static scheduling you need to have all the informations about the kinds of jobs, the resources they are going to use beforehand. On the basis of the kind of resources and the requirements, and of course the availability at the service provider's end, a schedule is generated. This schedule, it basically contains information about which task will be assigned to which resource, and after the schedule is generated, the actual execution will start. When the actual execution will start, the resources will be allocated at this point of time, not at the point of time that schedule is generated. So once the execution is started, the resources are allocated, and when the algorithm is running, no dynamic change at the point of execution will take place. All the changes, whatever the scheduling criteria is, that is decided beforehand in the schedule itself. So what the algorithm has to do now is it just has to follow the schedule and then assign the resources. So this is this diagram. It basically shows how the workload is being distributed amongst the different resources in a static scheduling algorithm. So we have a server, and the server has a lot of resources, and how these resources are being generated, and these resources are being assigned using a static scheduling algorithm is depicted in this diagram itself. Then the next one is dynamic scheduling. See, it is not always advisable to go for dynamic scheduling. Either you should go for static scheduling or dynamic scheduling, but the advantage of dynamic scheduling is that you can modify the algorithm depending upon the situation which arises. So all the parameters, everything is decided at the time of execution. So like in static scheduling, what happened was we were generating a schedule beforehand that this resource is going to be assigned to this task. In dynamic scheduling, we are starting with zero. We have no pre-information about how the algorithm is going to work. So how the algorithm is going to work, how the load is going to hit the service provider, and everything is taken care of at the runtime. So in case of dynamic scheduling, the resources are allocated at the time of execution according to the requirement. So what it means is we are not aware that how much resource a task will throw, resource request, how much amount of resources a task will require beforehand. So as and when a task comes up, the algorithm knows, okay, these many resources are being required and they are provisioned at runtime only. There is no pre-information about the resources beforehand. So you can also modify the resource allocation during the execution. So if at some point of time some situation that arises that some of these services, they are not available, or something is happening, so you can change the resource allocation at runtime itself. It is not like in static scheduling that you have to follow this and this schedule, that this task is going to be assigned to this resource only. That is not the case in dynamic scheduling. You can modify the resource allocation policy at runtime itself. So there are many dynamic scheduling algorithms which are built up. In fact, some of the dynamic scheduling algorithms, what the different researchers have done is they have worked towards making the static scheduling algorithms dynamic itself. So by how this can be done is they can tune in one or two parameters and then they can make their algorithms dynamics. For example, if we have an algorithm in which some resource is going to be assigned to some task, so if it is a static algorithm, what they can do is they can make it by dynamic, very dynamic, by just changing the amount of available pool, that by updating the pool of resources available at particular point of time, and then this algorithm will switch from static to dynamic. But of course they have their own pros and cons. Apart from that, we have talked about different job scheduling algorithms. Apart from that, there are many other job scheduling algorithms apart from the ones we have already discussed, like we have multi-objective task scheduling algorithm, then we have multi-level priority based task scheduling algorithm, then we have load balancing task scheduling algorithm, then particle swarm optimization based scheduling algorithm, and then energy efficiency based task scheduling algorithm. So there are different task scheduling algorithms which are proposed by different researchers. Apart from that, there are other algorithms, like we have cocoa optimization task scheduling algorithms, then we have green energy efficient based task scheduling algorithm, fault tolerant workflow scheduling algorithm, adaptive energy efficient task scheduling algorithm, and online optimization for preemptible task scheduling algorithms. So let's have a look at these algorithms. First one is multi-objective task scheduling algorithm. So what is happens in multi-objective task scheduling algorithms is that the scheduling algorithm, it will not have just one objective, that is to optimize resources. There can be multiple objectives. For example, in some of the algorithms, we can have two objectives, like to reduce if there is a deadline associated with, for example, if there is a deadline associated with a particular task. So what can be the different objectives? They can be, one objective will be to minimize the amount of resources which are being used, and the second objective would be that these resources should be used in such a manner that the deadline is met. So there are going to be multiple objectives for a single scheduling algorithm. So multi-objective scheduling algorithms, they are based on such kind of algorithms. So let's see, basically most of the scheduling algorithms, they minimize the make span without consideration of reduction in cost of services and other aspects also, like I just talked about the deadline thing. So these algorithms are also applied on single cloud environments. So basically, just like I discussed just now, that in case there are many algorithms which were based on single objective, that was just for reduction of the make span. Make span is basically the execution time, but they did not consider the cost effect. So if you are taking care of more than one objectives, like the make span, cost, or perhaps say the deadline, then your algorithm, it becomes a multi-objective task scheduling algorithm. Then there are other algorithms like multi-level priority based task algorithm. So in this algorithm, basically what happens is the scheduler, it divides the task into different levels, and then these resources are allocated to the task on the basis of the different levels. This algorithm, it basically emphasizes on independent tasks of the workflows. But the thing is, it is based on only one parameter, that is the priority. So on the basis of the priority of tasks, it will so if we have a set of tasks, these tasks, they are assigned with different priorities, and on the basis of these priorities, these tasks are scheduled. The only drawback is it is taking care of only one parameter, which is the priority, but these kind of algorithms can be stretched for other kind of tasks also. Then another kind of task scheduling algorithm is the load balancing one. What this algorithm does is, it does not consider the relationship amongst the tasks which are allocated and the node load. So if a task is allocated to an overloaded node, then this what happens is that in previous algorithms, what the tasks were doing is they were not taking care of how the tasks are being allocated at the node level. So what the node is basically the point in the service provider which is providing the resources. So what is happening is these different nodes, they will have different resources. So earlier what the algorithms were doing is they were allocating the task to any node, even if the node is overloaded. Overloaded means that this resource has a lot of tasks which are coming up, and it might happen that there might be another node which might not be having any task at all. So what will happen in this case is that the performance of the entire system will go down, because the tasks they might have to wait, or some other problem, there might occur a kind of deadlock, or there might be a increased amount of waiting time, or even if the resources are provided, they might not be provided in an optimal manner. So to take care of these kind of things, certain load balancing based task scheduling algorithms were developed. Another algorithm is particle swarm optimization algorithm, which we have already discussed, that there are many algorithms, task scheduling algorithms, which are based on particle swarm optimization. Even ant colony based algorithms are also coming up. Then we have energy efficiency based task scheduling algorithms, because I have been talking about that one of the major objectives of cloud computing should also focus on the energy efficient aspect. So in one of the algorithms which took care of the energy efficiency aspect, a dynamic voltage frequency scaling enabled energy efficient workflow task scheduling algorithm was proposed. What was its aim was to acquire more power drop. Power drop is to acquire less energy. It means that on top of quality of service. So what the basic objective of these kind of algorithms was to reduce the power consumption, that is the resource consumption, while taking care of the quality of service as well. What this algorithm did was it divided the tasks into in workflows to this these tasks they were in parallel, and then these tasks they were assigned the CPU. So what it does is it uses them at proper time, so that the overall power consumption it decreases, and of course the resource performance will increase in this case. So these algorithms are designed in such a manner that the power consumption is less, but the quality of service is also assured. And for the interested users, they can refer to this reference number 10, which these references will be at the end of my presentation. So you can always refer to these references for more detail about this topic. Then another technique for task scheduling is based on COCO optimization technique. So what this algorithm does is it uses COCO algorithm, which is very famous, to carry out the controls. See, so what happens is the cause of the proposed technique is attaining an order of processing such that the time of response of task is minimized. So the response time is minimized if we are going for COCO optimization based technique, and it uses a range of virtual machines, and the tasks are also in variety, and with the aid of examining the numerous orders of these machines. And then what it basically does is it allocates hosts to task. Host mean the machines, virtual machines, to task in a right manner by following the traditional COCO algorithm. Of course, if you want to go into more detail, you can follow this reference number 11. Then there are certain green energy efficient based task scheduling algorithm. this algorithm was based on priority of the task scheduling algorithms. So in this algorithm, basically these virtual machines, they are being assigned weights, and the service level on the basis of the weights of the virtual machines and the SLA requirements by the users, the tasks are being allocated the virtual machines. Then apart from that, we have other algorithms like fault tolerant workflow scheduling algorithm, adaptive energy efficient scheduling algorithms, online optimization algorithms for task scheduling, etc. This figure, it shows how one algorithm is better than the other one depending upon the different aspects, and you can always have a look at these this comparison and always see that whatever your objective is, whether it is met or not, depending upon your objective, you can choose the algorithm which you want to go for scheduling depending upon your requirements. So these are the references, and anyone who is interested in going into the details of the algorithms we have talked about can always refer to these links. I hope by the end of this lecture you would have got knowledge about how cloud scheduling takes place at the service provider end. So we'll stop here for today. Thank you so much.
With this one, thank you, ma'am. Thank you so very much for giving us this session on cloud computing. Dear friends, your feedbacks as well as your questions are welcome. We'll try to give answers to your questions when next time Dr. Kashishara Shakil visits our studio. So keep watching us, keep writing us at info.cec@nic.in. We are taking your leave with the promise that we are going to meet again soon. Thank you, ma'am. Thank you.